Go live. All right, sweet. So I am back in the classroom to go ahead and teach pre-calculus and other topics that I, really want to kind of get in throughout this year. So I do plan on adding in some more topics, not just in the pre-calculus. However, this year I am only teaching pre-calculus, and one of the things that I wanted to do this year is kind of like what I started off last year was, really doing some live streams, more often. And one of the things that kind of makes sense is for me to do the live streams after school, because when I get home at night, just with the kids and all the commotion, it's like way too much. So my goal, at least starting off into this year, is to get some live streams going from the beginning, or kind of like from the beginning of the year, and really try to keep this as something active and something that we're going to be going through, throughout the whole year as far as doing something that I can answer your questions, but also that I can provide, some value to those of you that maybe are not taking pre-calculus, but maybe want to, learn some other math topics or answer questions that you are currently going on in your own classroom. So the way that my structure is going to work for this live stream and for couple ones, and again, I'm willing to adjust here. So, but what I'll plan on doing is starting off with just working through the homework, just as I would to provide for my students. So give them value, as also giving you some value. And then what I'll do from there is, after I'm done, I'm trying to keep my homework rather short because I like something short and to the point. But then after I'm done from there, what I'll do is I'll kind of go into a little Q&A. So eventually, this week is our first week of school, so we haven't, everything's kind of been like crazy getting prepared. But what I'll eventually do is I'll start having this, scheduled. So therefore, those of you that are able to meet in this live streaming time, you guys can kind of have your questions and everything prepared, so therefore we can make it a little bit more proactive. So I know this was just kind of off the cuff. I wanted to go live and just kind of see Abdullah and Evan. I see you guys here. I'm happy to see you guys coming in here, and happy to be able to help you guys out. So let's get into this. Anybody else that kind of joins in, I'm just going to kind of work right through the homework, and then, as you have, I'll just kind of type in the chat, if you have any questions, just feel free to, let me know, and what I'll do is I'll try to answer some questions. I probably have about 30 minutes allocated, for this session. So whatever time after, I'll try to do my best. So I gotta move that in, so I'll get the stream. I guess I probably should have typed this up before I got everything going. Any questions? All right, so let's get on with it. It's been kind of a crazy day of teaching, but I'm happy to get back to doing some live streams. And I tried to do it. In the class today, but it just wasn't really working out. So again, I'm going to kind of go about probably about 10-15 minutes here straight through this homework, and then I'll kind of answer some questions from any of you guys that have them. So I don't have my intro loaded up, so we'll just kind of go from here. All right, welcome. So what I want to do is cover characteristics of functions. So what we're going to do is we're going to work on identifying some of these key characteristics here from these two graphs. And then we're going to work on given some characteristics if we can sketch the graph. And then what I've done is I've also pulled some multiple choice questions that you may see on an exam, a quiz, or a test. And then also a little bit of just some challenge problems just to make you think. Something that might be a challenge for some of you, might not be a challenge for others, but it's really something that we don't discuss in class to kind of get you further thinking a little bit more deeper on the information that we're covering. So let's get on, start with the first one here. And, we've already kind of covered these notes in class, so I'm not going to get deep into the discussion of, what all of this works or why, but, I will try to explain it, at least, so you can kind of verify if you're not understanding why some of this works. So the first one is looking into the domain and range. So if I want to identify the domain of this function, first of all, I can see that it is a continuous function. So therefore, this graph is going to continue expanding to the left and to the right. I do not have any discontinuities. There's no breaks in this graph. So therefore, this graph is defined for all x values, basically all real values of x. It's going to, all x values make up this graph as it continues to the left and continues to the right. So the domain in this case is going to be negative infinity to infinity. Now, when we look at the range, we're basically looking at what is going to be, the y values, a set of all y values that make up this graph. And again, you can see that there's really no breaks or holes in this graph. So this graph is going to continue down, being more negative and continue more positive, and all real y values are going to be contained. So therefore, that would be from negative infinity to infinity. All right, part B is looking for increasing, decreasing values. Now again, when we're looking for the increasing, decreasing intervals, I guess I should say, we're really just looking for when. So when is the graph going up or down? And the key distinction here is really how we read the graph. X is basically telling us when as something is applying, and Y is basically telling us, how high or how low it goes. So we're just looking for the X values to identify our intervals. So first of all, this graph continues going to the left towards negative infinity. And then you can see, though, as I kind of trace this graph here, I can see that I am going up. So I don't want to say what I'm going up or how far I'm going up. I just want to say what x values am I traveling up. And those x values, you can say increasing, are going to be from negative infinity all the way up to, let's see, that x value is at negative 2. And then you can see, then I go up, and then I'm going down. So these are my decreasing values. And then the graph again turns to go up increasing from the x value of 2. Sorry, I got to use our parenthesis. So then from 2 to infinity. Now, I'm not using included brackets to include the points, because at any given point, you can only be increasing, decreasing, or constant. You can't be both one and the same. So that's why I'm using these excluded intervals for the increasing, decreasing values. And so now let's go and cover decreasing. So the decreasing values are going to be from negative 2. So you can see the x value, negative 2. We don't care how high it is. We just know from when x equals negative 2 to when x equals 2, the graph is going down. So that's how we're going to describe increasing, decreasing values. All right, part C and constant, but the graph is not constant anywhere. Part C is going to be discontinuities. Well, we kind of luck out with this one because this graph is continuous. And again, we can determine this discontinuous by being able to sketch it without lifting up our pen. So this one is continuous. Don't like drawing on that. All right, let's go and look at D, which is going to be the extrema. So when we're looking for extrema, basically, I got to keep that up higher. Sorry about that. So when we're looking for the extrema, in this case, basically what we're looking for is looking for maxes and mins. And we can look for max and mins on the whole graph, like zoomed out, right? What is the absolute maximum, maximum, minimum? When we see that there is no absolute maximum, because this graph continues going up and continues going down. So there are no absolute maximum or minimums, which would be extrema. However, if we were to zoom in, and this is I love this because here's my description that I talk about with my students. If I'm able to zoom in here, oops, oh, it's only allowing me to zoom in so far. Dang it. But anyways, if I was to zoom in and I could only view this area, all right, that's what I could zoom into. You could see that this point is now a maximum within this screen, right? It's relative to me only looking within that screen. As I zoom out, you see that values go above that. So this is what we call a relative maximum. And again, it's a maximum because points to the left as well as points to the right are below that value. Now, the same thing can be said here. This is not the lowest point of the graph, right? There's points that go farther down. However, relative to me zooming in right here, you can see points to the left and points to the right are above this. So this is what we call a relative min. So I'm just going to go ahead and write those as my extrema. So I'll have a relative max at, let's see, that's what, negative 2, 2, and then 2, negative 2? Okay, so negative 2, 2. And then I have a relative min that is at 2 comma negative 2. Sorry, I should probably leave more space, but I know I'm kind of leaving on there. Let's go even, odd, or neither. So when we're looking at even, odd, or neither, what we're doing is we're looking at this graph and it's checking the symmetry. If the graph is symmetrical about the y-axis, it's even. If it's symmetrical about the origin, meaning we can reflect it about the x and the y and get the exact same graph, then it's going to be odd. In this case, you see this graph is reflective about the origin. If you flip it about the y-axis and flip it about the x, you get the exact same graph. So this is an example of an odd graph. I don't know why I wrote ed. All right, and the last one, F, is boundness. Boundness is basically looking at the restrictions on how high or low this graph is going to go. And so if something has an absolute maximum, we would say it's bounded above. If it has an absolute minimum, we could say it's bounded below. So this does not have an absolute max or min, so it's unbounded. It continues without bound. So this is be an example of an unbounded function. And then now we get into G, which I think was just end behavior, or H, F. Oh, I forgot A, G. Oops. So let's go into H. So H is roughly just going to be end behavior. And again, end behavior is looking at, so if I keep on zooming out, if this graph keeps on expanding to the left and the right, where is it going? So as I view this graph moving left and moving right, where is it going? And in this example, you can see that the graph is, moved rising to infinity and falling to negative infinity. So we'll talk about more of a mathematical way to represent that later, but for right now, we can just say the graph rises right and falls left. Okay, so now let's get on to the next example. Same kind of thing, but now we're looking at a graph. We see this dashed line. That's representing a vertical asymptote. You can see that the graph is approaching this vertical asymptote, but the graph is never going to exactly cross it. And then we also have this nice little hole. It's just a little dot here inside this function. All right, so if we're looking for the domain, we can see that this graph is never going to cross this vertical asymptote. So it's going to stay to the right of the vertical asymptote. But however, within the actual graphing it, I can't graph it continuously because I have this, hole here. So I have to jump over the hole to continue graphing it. So therefore, this hole is my discontinuity, and that's going to break up my domain. So the easy way to do domain when you have a discontinuity is just determine the domain to the left of the discontinuity and then the domain to the right. So my domain in this case is going to be from -2. Now, my graph never reaches -2 because that's the vertical asymptote, so that's undefined. So it goes from -2 to +2. And again, it never reaches 2 because that's an undefined value. And then union 2 to infinity. You don't need to include the union, but I think it's kind of a best practice to understand that those are connected. As far as the range is going to be basically the set of all the y values. And you see that this graph is going to continue down to negative infinity, and this graph is going to kind of continue up to infinity, very slowly, but it will. The only undefined value in this case here is 0, right? There is no other point where y is going to equal 0. So the range in this case is going to be from negative infinity to 0. 0, again, is undefined as a y value. Union 0 to infinity. Let's look at part B, increasing, decreasing, or constant. Well, you can see as we kind of read this graph from left to right, you can see the graph is always increasing. The problem is that we have this discontinuity. So we don't want to be lazy and say, well, from -2 to infinity, it's increasing. While that's true, if you say it that way, that implies that at the x value 2, the graph is increasing, which is not true. The x value is undefined at 2. So if we're going to write the increasing intervals, we're actually going to have to break it up based on the continuity or discontinuity. So we'd say -2 to +2 as well as 2 to infinity. And again, we're describing the increasing behavior based on the x values, not how high the graph is going. Next thing we want to talk about, the discontinuities. So there's two different types of discontinuities. We have removable and non-removable. And once we get into more of the algebraic applications of discontinuities, it will make a little bit more sense. For right now, we can just say that vertical asymptotes are non-removable and holes are removable. And it might not make sense, but we'll just have them down, and once we do the algebra, it'll make more sense. Now, the issue, though, is this vertical asymptote is actually not a discontinuity. A discontinuity is something that breaks apart the graph. There is a vertical asymptote here, but that's just where the graph is approaching. That's not actually breaking up the graph. So even though in this case we have a vertical asymptote, it's not a discontinuity. All we have is one removable discontinuity. So we just say it's a removable discontinuity. We could say it's a hole. And we could also say like where that occurs. Where it occurs at x equals 2. Right? So we want to talk a little bit more. We want to talk about if it's removable or non-removable. Sometimes we might be asked, to describe what type it is, and then where does it occur. Part D is going to be doing extrema, which this is a nice one because you can see that this graph really never continues going down, never continues going up. It never changes from increasing and decreasing. If you notice here, when this graph changes from increasing and decreasing, we created an extrema. When we change from decreasing and increasing, we created an extrema. This never has any of those ups and downs for us to be able to have an extrema. So there are no extrema in this example. If the graph is even, odd, or neither, well, again, we got to look at symmetry. And you can see that if I flip this graph about the y-axis, I don't have anything symmetrical. And if I flip about the origin, again, I'm not going to have any symmetry as well. So this is neither even nor odd. And then last but not least is our end behavior. Again, if we look at this graph and expand out, we can see as we view this graph to the right, it's going up to positive infinity. But as we view this graph to the left, it's continually going down, but it only goes down as far left as this, vertical asymptote. So technically, it's not continuing going down left, even though as it continues going left, we could say that it's, going down to, negative infinity. So the end behavior is falls left. In this case, rises right. Okay, so now let's go and look at another example here where now what I've done is I've given you some actually directions as far as what to do in this case, and then now what we're going to do is identify the discontinuities for this. We're going to sketch the graph. So there's a couple things we want to do here. We have intervals where the graph is decreasing. So we have from negative infinity to 0, and then from 0 to 2, the graph is decreasing. And the graph is increasing from 2 to 4. It has vertical asymptote at x equals 0, so I can just kind of draw that here. All right, that's fine. I can draw the x equals 0. Has a non-removable discontinuity at x equals 2. So if it's not removable, it's probably going to be like a jump, or it could be a vertical asymptote, I guess. I mean, it doesn't really get, I think here I'm defining it being a vertical asymptote. Here I'm not, so I guess you wouldn't want to assume that it could be, but I guess that's not technically wrong. And then here we have f is 3 equals 5. So 1, 2, 3, 5. So that's a coordinate point on the graph. All right, so we're decreasing, and then at 2, so we're decreasing from 0 to 2, and at x equal 2, and increasing from 2 to 4. So let's see, from 2 to 4, we're increasing. So let's maybe make a dot here. And I don't know. From 2 to 4, it's increasing, and then we don't really have any other information there, so I'll just put a dot there. I have a non-removable discontinuity. Let's just do it as a jump. So let's see, from 0 to 2, what is it? It's decreasing, right? So let's maybe go from down here. And there's a vertical asymptote at 0. So we want it to be approaching the 0. Okay, so from 0 to 2, it's decreasing. There's a non-removable discontinuity at 2. And then from 2 to 4, it's increasing, and it contains the point 3, 5. And then it's also decreasing from negative infinity to 0. So, maybe let's just draw something going down from negative infinity to 0. Something like that. Okay, and unless I missed anything, I think that's roughly pretty case. And obviously, there's no right answer here. There's multiple different ways you guys could sketch a graph. But the main important thing is that for it to be decreasing on those intervals, increasing there, contains that point, contains a jump discontinuity, and it's approaching the asymptote. All right. Let's go and work through the multiple choice, and then I think I'm done. I'm not going to continue on the challenge. I'll try to get to you guys that have kind of been following along so far. So if we want to find the domain of the function, because I only have about 10 minutes. So if we want to find the domain of the function where the graph is shown below, all right, so we're looking for the domain. Again, that's a set of all x values. Basically, you see this graph is continuous, so therefore we just want to look how far left to how far right. Now, the graph is kind of hard to see, but it looks like that is going to be at 1. It's crossing. So, and that point is solid, so therefore it's included. So we're looking from 1 and then all values larger than 1, which go to infinity, so that's going to be B. Part number 4 is determining the values where there's a local maximum occur. So again, a maximum is any point to the left and to the right are below. Well, the only thing that we have here is a absolute. So notice the verbiage here is local, and we're dealing with an absolute. So it's telling us where all these local maximums are. There is no local maximum, okay? And if you're interested in the challenge problems, feel free to kind of, go into them. I do have some more of this work, and, in future live streams, I'll kind of let you guys know where you can get access to a lot of this work if that's something that interests you, especially if you're taking pre-calculus or in Algebra 2 or college algebra, those things that can help you out. But otherwise, that will be end of my, at least the homework, and now let's kind of get into some Q&A. So I'll open up this screen a little bit more to kind of see you guys. Scroll back. I appreciate you guys joining in with me. Nishant, hello. Shudelo. Anthony, are you going to work on one-sided limits for calculus? Anthony, I plan on doing some calculus stuff, so I might be a little bit behind your class, but that's one of the things that I want to kind of get into is making some videos after school kind of based on calculus. So yes, that is something I will be doing. Hey, Samajan from India. Glad you're able to jump on. That's awesome. And Hamish, you asked differential equations, please. Well, I'm not teaching calculus this year, so typically when I do my stuff on YouTube, I just kind of follows the the progress that I'm making throughout my course, and that's kind of some things that I will kind of be doing. But since I'm not teaching calculus, it's going to be a little bit more difficult. So what I'm going to do is I'm going to decide to kind of like pick some topics, still kind of in that sequential order though, to teach kind of throughout the year to kind of help out some people that are taking calculus students. Sahil, we have not covered transforming graphs and the modulus function. We will be getting into that next week. So if you stay tuned, we will have some of that going on. I already have some notes and everything like that prepared. So yeah, we'll be probably covering that probably next week sometime. I'll be covering a lot of that stuff. So it will be uploaded for you guys. Now the other thing I just want to kind of ask lastly for you guys, unless anybody has any questions, I haven't if any of you guys have any math questions, I am more than happy to kind of continue on and answer any questions. But one thing that I'm looking into is seeing if I can continue doing doing the homework as a live stream, or if maybe it might be more beneficial to kind of get into some Q&A and just really answer some questions. So if you guys want to maybe let me know, like, what do you think? I mean, is it beneficial for me just to kind of talk through the homework? And, you just kind of watch me go through a homework assignment and explaining the mathematical topics. I know, obviously, I'm doing that for majority of the students in my class so they can see what they're doing. But as far as for you guys, watching the stream, is that something that's beneficial? Or would you rather have something that is more organized, is, scheduled out, and therefore you can bring in a lot of the, questions that you have? The problem with going on just a pure question format is I want to make sure I can provide as much value as possible to everybody. So if I'm answering questions on all different topics, I think it can be hard for everybody to really enjoy the stream. On contrary, when I'm talking about, hey, this live stream's on characteristics of functions, well, if you don't want to learn anything on characteristics of functions, then you don't need to stay tuned, right? If you're doing something that doesn't really matter, then you would skip it, and you maybe wait for a live stream that is a little bit more beneficial for you. Or if you have questions you want to ask me, you can go ahead and do that. So any kind of advice or comments that you guys want to add to that, I'd be really happy if you guys can get in with that discussion and kind of let me know what you feel like would be the best kind of move forward. Because, I have about 30 minutes about twice a week that I want to allocate to doing some live streams. So I want to hear from you. I want to hear what's going to kind of, work to make it the best for you guys. Kino says, for the question you did that was multiple choice, could it also be D? Okay, so the difference between B and D is B says that one is included, meaning it's a part of the domain. And D says one is not included, so it's not a part of the domain. So that's really kind of like the difference. If the graph for D would look something like this. Like if it looked something like that where there's a hole or an asymptote, sometime where one is not actually defined for the domain, that is when we would use the that parenthesis. So the bracket is what helps us allow from that. So hopefully that helps you guys. All right. Well, if you guys don't have any questions, I'll plan on coming back and doing another live stream next week on Tuesday and Thursday. And we'll kind of see how it goes from there. I do have some, more information that I want to kind of cover, and maybe I'll do this first section. I think I'll at least cover functions in this format, and then, I'll hear from you guys, see how it kind of works, and if that's something that's, is working for you as well as my students, then I'll continue it. But if you guys have any other further questions, I would love to hear from them, and now it's time for me to make some more videos. So cheers, guys. Hope you enjoy the rest of your day, evening, morning, wherever you are. Uh-oh, now everything got messed up. Oh, there it is.